Okay, so we finished up with 14, now we're moving on to 15. When you're trying to figure out what situations can be modeled by an exponential function, well, you gotta read each of these and figure out which ones can and can't. Fortunately, this one's A, just like the first one you read, and you'll know because it grows by a percent each year. If you're doing percent growth or percent decrease, it has to be exponential. The linear models don't do the percent stuff. And if you read the rest of these all follow an arithmetic or linear situation. Increasing by 25 each year, that's like a common difference of 25. Decreases by 10, that's just like subtract 10 every year. And then stays the same, that's just a horizontal line if you were to graph it. And so that's also linear. And that leaves us with A. 16. Getting the number of people in the slopes X hours after 6 p.m. What's the percent of people that remain from 1 hour to the next? If you're trying to do, like, what's the percent that remained or whatever, you just take any number in the sequence and divide by the previous one. So if you do, like, 90 over 270, that comes out to be 1/3, which if you convert it to a percent, so you, in your calculator, push 1 divided by 3, you get this really long decimal of 3 repeating forever. Well, that's 33%. And so the answer is going to be B. 17, which function describes the relationship between hours driving and the number of gallons of tank remaining in the, number of gallons of gas remaining in the tank. In order to get this function here, you have to figure out what the pattern is. And the pattern here is subtract 4 every time, so we have a common difference of subtract 4. And here, don't forget to look at your x values. That one's adding 2 every time. And so this one follows a linear function. Remember, like you got your y equals mx plus b form. The b is your starting value. And then the m, the slope, you got to do change in f of x or change in y over the change in x. And when you do that, you got -4 over 2, which is a slope of -2. So if you take -2 and 16, those become your two values for b and m. So A matches that function. 16 is not with the x, so that's B. The -2 is with the x, so that's the m. And so, yeah, that matches up our numbers. 18. Petri dish starts with 1 cell. Each hour it's going to split, make twice as many. If x is the number of hours, which function represents the number of cells in the Petri dish at any time? Well, we start with 1, so you can think of a sub 1 as 1, and our common ratio, because it's multiplying, is 2. And so if you were to write your function like we have with the sequence stuff, you do 1 times 2 to the n minus 1 power. And again, we're trying to figure out which of these matches up with that. A is linear, definitely not matching. B, really, really close to what it could be. C, also really, really close. And D is linear, so those are out. So it's a battle between B and C. You have to think about what the initial value is to determine whether or not it has that +1 on the end. If you plug in your function here, you notice how these all have 2 to the x here, and so we're not going to use this one, but it gives us a head start. We know we got to have 2 with an exponent. We'll plug in 0 into both of these and see which one gives you a start value of 1. If you plug it in the top one, you're going to get 2 to the 0 plus 1. Well, 2 to the 0 is 1, so that's going to give you 2. If you plug it into the second one, you're going to get 2 to the 0, which is just 1. And so that's why C is the answer for this one, because the start value is 1. 19. The function value here, and then you got another function. You're trying to figure out when does the value of f(x) become greater than g of x. Well, you just look at your graph here, and it starts becoming greater at that point right there. And notice how all these are talking about the x value. Well, look at your x value there. That's 1. That's going to go from 1 and onward to the right. And so, we're going to write the inequality as x greater than 1. On 20, what's the left end behavior? That means you get on your graph and you head left forever. Over there at negative infinity for x, as in left forever. What's the y value? Well, the y value is this guy here, which is negative 2, down here at the bottom there. And so we're going to write f of x goes to negative 2. And on 21, which of the following points is not a solution to the equation? To figure this out, you have to take each of these points and put it in, take each of the x values, put it in for x, and see if it gives you the corresponding y value. Okay? Well, if you take the first one, you plug in negative 1, 3 to the negative 1 power is 1/3. And so you're going to have like 1/3 minus 5. Well, that is not equal to negative 8, which is supposed to be the y value there. And so A would not be a solution. But if you plug in any of these other ones, right, if you plug in 0, you're going to get negative 4. If you plug in 1, you're going to get negative 2. If you plug in 2, you're going to get 4. Okay, so each of these is a solution. Just A is the one that's not. And that's going to be up to 21.